della Università Guglielmo Marconi. Il secondo presentatore è Christian Andreas Schumann della Università de Ciencia Applicada de Zwickau in Alemania. So good morning and welcome to the session number 7 on the personalized and responsive feedback system in distance learning. We will have two speakers in this session. The first one is Professor Ernesto Grande from Guglielmo Marconi University, while the second one is Christian Andreas Schumann of the University of Applied Science of Zwickau in Germany. So I ask to the speakers to remain in the time slot that we have dedicated, and at the end of the presentation we will have a time slot for the questions. So I ask Ernesto to start with his presentation.
Okay, thank you, Matteo. Good morning. This is my first experience at the conference guide. Okay, good morning. This is my first experience at the conference guide. In fact, as the moderator has already said in introducing me, at the moment I'm Associate Professor of Structural Design at Marconi University in Rome, about from 1 year, while in the past years I was Assistant Professor still of Structural Design, but not at an online university. So this has given me the opportunity to compare different teaching approaches just for the course of structural design, and then to propose the topic of my presentation, that is the virtual academic laboratory structural design. Structural design is one of the main courses characterizing the first level of degree in civil engineering. The main goal of this course is to give a general overview on the design of structures, together with specific information concerning the design and the verification of structural members. The traditional face-to-face teaching activity for the course of structural design is mainly based on lectures devoted to illustrate the concepts of the theory and also examples of numerical applications. In particular, numerical applications play an important role within the course of structural design. Nevertheless, since they are presented during the development of the course, they generally only concern specific topics of the course of structural design. For this reason, at the end of the course of structural design, it is generally required to perform the structural design of a case study considering a full design part. And also, during the development of this case study, a face-to-face revision process with the teacher is carried out with the twofold aim. The first one, to assess the outcomes derived by students, and the second one, to check their ability in understanding the importance to follow the design path. In the case of distance learning, video lessons, virtual room, training aid, etc., certainly represent efficient tools both for explaining the concept of the theory and to present numerical applications of structural design. On the other hand, in my opinion, they don't completely allow to cover the other important part of the course, that is the structural design of a case study, considering a full and clear design path and a step-by-step assistance process. For this reason, taking into account recent examples of a virtual academic laboratory presented at Marconi University, I've decided to propose a virtual academic laboratory just for the course of structural design. The main goal of this laboratory is to improve the skills of students with the development of numerical application of structural design, but involving and assisting them in a clear design path. So, the structure of the laboratory structural design is very simple. It is composed of 4 main sections. The section 1 is devoted to the selection of the type of the problem, that is the design or the verification of a structural member, and to the case to examine. In the library of the laboratory are presented many examples. The section 2 concerns the derivation of the design laws and the design actions according to the specific indications contained in the Italian code. The section 3 concerns the identification of the class of materials, still considering the specific indication contained in the code. And finally, the section 4 concerns the derivation of the final solution of the problem. So each section is strictly correlated to the other ones, in the sense that the results derived at the end of each section are used for the subsequent ones. Moreover, each section is enriched by tools and information which update during the development of the problem. Among these tables containing the initial input data, but also the results derived by students at the end of each section. Excerpts of the code which allow students to consult specific information of the code by remaining in the environment of the laboratory. Help assistance tool, which helps students by providing, for instance, notes from the theory or suggestions for the development of the problem. And finally, the automatic generation of two important documents. The first one containing a summary of the correct procedure to consider, and the second one is a feedback for the teacher responsible of the laboratory, which contain information about the choices made by students, possible mistakes, the number of times students use the help tool, the excerpt of the codes, etc. So, in order to show in detail the mode of operation of this laboratory, I present a simple case just derived from its library. This case consists of, in a simple supported reinforced concrete beam, and the aim of the problem is to evaluate the amount of steel of this beam. So the first window characterizing the laboratory is shown in this slide. It contains a short text of the problem, a picture of the case to examine, and a table containing the input data. So for this picture, for this window, it is clear the problem, but also the announce of the problem. In fact, many details graphically reported in the figure are not included in the table. So the students are introduced in the section 2, sorry. The aim of the section 2 is to derive the design loads and after the design action. So, in agreement with the real design paths, the derivation of the design loads depends on factors directly derived from the code. So, for this reason, the window characterizing this first phase of the section 2 also contain an excerpt of the code where all the safety factors are reported. So students opportunely selected the two safety factors, introduce them in specific cells of the window, and the system performs a first check. So if the safety factors are correctly identified, the system introduces the student in the second phase of the section 1, that is the derivation of the maximum design actions. This second phase of the section 2 is characterized by interactive diagrams of the design actions, which help students in select the maximum values of the design actions and to introduce them in specific cells of the window. So, students are introduced in the section 3. The aim of the section 3 is to identify the class of materials, concrete and steel. So, still in agreement with the real design part, the identification of the class of material is strictly related to experimental tests, real experimental tests on materials. For this reason, the windows characterizing this phase contains pictures of real apparatuses generally used for performing these types of tests on material, and in particular simulations of experimental tests, both on concrete and steel. In fact, students start the simulation. The system automatically generates and randomly the values of the compressive strength in the case of concrete. Then students, on the basis of these values and by consulting the specific excerpt of the code, are able to identify the class of the concrete. The same organization is also provided for the steel. This is very important because students can understand the difference between steel and concrete in terms of type of tests, parameters derived from the test, and specific indication contained in the national code. So finally, students arrive at section 4. The aim of the section 4 is to derive the final solution of the problem, in this case, the amount of the steel in this beam. In particular, in a first phase of this section, students derive a preliminary solution only by taking into account the design actions derived at the end of the section 2 and the class of materials derived at the section 3, at the end of the section 3. And then they can use also the tool assistance, which furnishes draft for the theory and suggestions. This solution does not guarantee the compliance with the code. This is also in agreement with the real design path. In fact, students have to check the compliance of this solution in terms of amount of steel reinforcement in the beam with the specific indication contained in the code. And eventually, they have to modify the solution previously obtained. So at the end of this design part, the two documents are automatically generated by the system. The first one is available for students, represent a training aid. The second one is sent to the teacher, is a feedback document for the teacher. So in order to conclude my presentation, just a few remarks and future possible developments. Regarding the remarks, the structure of the aim of the virtual laboratory is to improve the skills of the students with the development of numerical application of structural design, but by assisting and involving them in a clear design path. This requires to merge all the concepts of the theory. The second observation concerns the structure of the laboratory. The structure of the laboratory is very simple. It reproduces a design path, and just this simplicity of the structure allows to introduce additional examples without introducing significant modifications in the structure. About future developments, our intention is to introduce additional functionalities, for instance, devoted to carry out also the drawing of the derived solutions. So just at the end, many thanks to all the staff of the Marconi University involved in this preliminary idea, translated in an effective project. Thank you for your attention. There is a short video.
Yeah.
The laboratory on building construction techniques stems from the need to give an answer to two types of queries: to design the flexural and shear reinforcement of a reinforced concrete beam, and carry out the flexural and shear verification of these. The use of the laboratory begins with the choice between the project stage and the verification one, and contextually from the choice of the case of interest. The problem to address is presented, and the static schema and chosen load are illustrated. This is accompanied by a table with initial data of the simulation. The the student moves on to calculate the maximum stresses. Since an ultimate limit state verification is requested, we need to pass the characteristic values of the loads to the corresponding project values. After knowing the static schema and the value of the load project, it is possible to determine the maximum value of the stresses of the bending and shear moment through the use of interactive graphs. These graphs automatically supply the diagrams of the stresses and allow the students to instantly detect the maximum values. Students will then find themselves dealing with the evaluation of the resistance characteristics of the materials used. They will go on to determine the resistance class of concrete through crushing simulation tests on the 3 cubic samples according to Type A control. They will then do a class check for steel to understand whether it can be classified as B450C. In this stage, students are supported by images of real tools as well as the law guidelines. Up until this step, the table relating to the project query and the one relative to verification are updated with the same data, while for the final part, different sizes will go on to complete the relative paths. In the case of project, in order to evaluate the flexural effects, the preliminary calculation is done on the theoretical reinforcement intention. The preliminary solution, deducted on the basis of theory concepts, is therefore adapted by introducing commercial reinforcement diameters. Suggestions given by the help option will guide the student in the choices to make and in the calculations to do. We proceed by going on to check the limits on the amount of reinforcements requested by Italian law. We then move on to the calculation of the shear reinforcement and the parameters relating to the brackets. Even in this case, the control on the amount of reinforcements requested by law are foreseen. At this point, the student has finished the path and can send a report of the work done to the teacher by email. The automatically generated report contains all the choices made, the outcome of the controls during the different stages, and the subsequent changes, attempts in the case of a negative outcome. The teacher, on the other hand, will evaluate what was received and will give a feedback. The completion of the laboratory allows the student to consolidate the theoretical concepts acquired during the use of the didactic course material, and especially by applying these concepts in the different steps characterized by the structural design of elements, reinforced concrete beams, which are recurrent in design practice.
So thank you Ernesto for your presentation.